Okay guys, here we are with the last part of the sig figs presentation. So this will be for the integrated people topic 3D, and what we're going to do here is we are going to be doing math with correct significant figures, and that combines our ability to identify the number of significant figures and then to round a answer from our calculator to a specific number of significant figures. So it really requires the skills that we talked about in parts 2 and 3. So let's skip over all the slides that we've done before. Okay, and we're going to begin here. And let's say that we have done a really trivial lab where you have to calculate the density of something. And when you calculate the density of something, you need two measurements. You need a mass measurement and a volume measurement. Obviously, you can't measure volumes on a scale, so we need two pieces of equipment, like a scale to measure our mass and a graduated cylinder or something to measure our volume. And those two pieces of equipment are probably going to have different amounts of precision, which is what our number of sig figs allows us to do. It allows us to compare the precision of a measurement taken on one instrument to the measurement taken on a different instrument. So comparing, in this case, a scale to a graduated cylinder. And we can see here that based on the measurements, the way they were recorded, we have different amounts of significant figures. So this would tell us that our scale is the most precise, while our graduated cylinder, it's less precise. And that's because this measurement has 5 significant figures and this measurement only has 3. So we get those and we plug our measurements into our calculator, mass divided by volume, and our calculator gives me this, which has a whole bunch of significant figures. Depending on your calculator, it might have even more than that shown. So the question is, do we get to keep the number of significant figures that our calculator says? A lot. The number of significant figures of our best measurement, or the number of significant figures of our worst measurement? And the answer is that you get to keep the significant figures of your worst measurement. And that kind of goes back to, remember our analogy about the auditorium full of people? You look at and you say, oh, 200 people. That's kind of a pretty poor measurement. It's just a really rough estimate. But then you see 4 people walk in. That's a precise measurement. 4 people exactly. When we added those 4 people to the estimate of 200, that's adding a good measurement, high amount of precision, to a bad measurement, low amount of precision. And so our answer was there were still only 200 people in that auditorium, because our answer can only be as good as our worst, least precise measurement. So in this case, we would look at this and we would say, I have 3 significant figures in my least precise measurement. Therefore, I'm going to round my calculator's answer to 3 sig figs, and you would report this as 8.72. So now let's go and look at some examples. This is for the chemistry kids. Mercifully, you guys will not have to do addition and subtraction if you're in the graded class. Chemistry guys will actually have to come back for a part 5 for this. Sorry about your luck, chemistry nerds. Okay, so we're going to look at some examples here, and again, I'm not going to do any of these addition and subtraction ones. I'm only going to be doing multiplication and division with integrated. So I'll do a few of these and leave the rest for you to do. I'm going to do A, B, and C and leave you guys to do D through H. So the first thing I'm going to do is I'm going to look at these numbers, and I'm going to decide which one in my problem has a smaller number of sig figs. So 651 times 75. This has 3 sig figs, and this has 2 sig figs. So whatever my calculator says, I'm going to take its answer and round it to 2 significant figures, because that's the smaller of the 2 measurements in my problem. So consult the calculator. It tells me 48,825. And so I'm only allowed to keep the first 2 significant figures. So that is going to be the 4 and the 8. Look one past it, decide how I'm going to round. 8 rounds this 8 up to a 9. So there's 49. That has 2 sig figs, but it's not very close to the original number, which was 48,825. So I need 3 placeholder zeros. And this would be your correct final answer for the first one. Okay. 7.835 divided by 2.5. This has 4 sig figs. This has 2. It's 2.5. So whatever my calculator says, I get to keep 2 sig figs. Calculator says 3.134. 2 sig figs would be the 3 and the 1. The 1 doesn't get rounded up, so my answer is 3.1. And when you round after the decimal, you just get to where you round and then you chop everything off. So I don't need to put any zeros there, and that is my correct final answer. Lastly, I want to do 14.75 divided by 1.2. Switch colors here. Forgot to switch. Anyway, this has 4 sig figs, and this has 3 sig figs. So my calculator's answer gets to have 3. Calculator says 12.2916 repeating. So I need 3 sig figs. That's going to be 1, 2.2. The 9 rounds the 2 up. So my correct answer is 12.3. And again, when rounding after the decimal, get to where you want to round and chop everything off. So this is the final answer there. So sum it up. When you're doing math with correct significant figures, you'll need your calculator. You'll look at the numbers and decide which one has lower sig figs, and you'll perform the calculation. Take your calculator's answer, so whatever the calculator says, and round it to the lesser of the significant figures. And that's what you'll need to record as your answer for these problem types. Thanks, guys. Hope this helps, and we'll talk to you later.